Today's lesson is algebraic representation with vectors. My learning objective is I can perform vector operations using scalar multiplication and vector additions, including the addition of negative vectors. We'll be using the law of sines and law of cosines, so I have the formulas on here for some reference too. Let's start out with, I want to draw vector v, where A is at 0.47 and B is at -4,3. I want to draw the vector equal to V at the initial point where it's at the origin. Okay, so I'm going to plot my 2 points, 4, 7, so 1, 2, 3, 4. 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 4, 7 is point A. B is at -4. 1, 2, 3, 4. 1, 2, 3. And B is at 3. -4, 3. So here's my vector AB. I'm going to box it out into component form. So my horizontal, 1, 2, 3, 4, 5, 6, 7, 8 is -8. And 1, 2, 3, 4, and my vertical is -4. So I'm going left 8 and 4 down. So to have my vector v at the origin, I want this to start here, and I'm going to go left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 4. 1, 2, 3, 4. So my initial point is at the origin, and I'm calling this vector v. So the vector positioned at the origin is called the component form. So I show it kind of like a coordinate because one point is 0, 0. So this is going to be vector v, which is -8, -4. And then I use these types of brackets, these pointy brackets, to show that I have a vector. Okay, so in component form, we can also say this in terms of what we call I and J, where I is the horizontal change and J is the vertical change. So vector 3, 4, or I could say vector 3i plus 4j. These are equivalent. They're the same thing. So there are two different ways. So electrical engineering uses I and J, and physics uses these pointy brackets. So there are two different branches of science. Okay, so the component form of a vector is equal to the initial point at the origin and my vector is the change in x by the change in y, or I can subtract. So x2 minus x1 and y2 minus y1. So this is, I'm just finding a distance. So I subtract to find a distance. And my 2 points are x1 and y1 and x2 and y2. So I'm subtracting to find the distance horizontally and vertically. Okay. Okay, for my 2 points A and B, find A, B, and component form, and then find the magnitude. So in component form, here's x1, y1, x2, y2. So I'm going to plot my 2 points. A is at -8, 3, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. And B is at -2, -5. 1, 2, 3, 4, 5. So here's B. So here's my vector. So I want to box out my vector. So the component form is 1, 2, 3, 4, 5, 6. So 6 to the right. And 1, 2, 3, 4, 5, 6, 7, 8. And 8 down, or -8. So in component form, when I want to put this at the origin, so the component form, so I can subtract these. So I can say x2, so -2 minus -8. So x2 minus x1 and y2 minus y1. So -5 minus 3. So -2 minus a -8 is 6. -5 minus 3 is -8. So I'm going to, these are what I see for horizontal and vertical on my graph. So then I'm going to plot my vector at the origin. So I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. And down 8. 1, 2, 3, 4, 5, 6, 7, 8. So here is my vector, and I'm going to call it vector AB. So my magnitude, to find the magnitude, this is the Pythagorean theorem. So this is going to be 6 squared plus -8 quantity squared, 36 plus 64 square root 100 is 10. So the magnitude of vector AB is 10. Okay, so let's perform some operations. Let's look at it in a different format. So I'm going to give you the vector as u and v, and I'm going to give you the component form. So I'm going to add u plus v. So I'm going to add horizontal plus horizontal. And then I'm going to add vertical plus vertical. Let's see what's going on here. How come it's not working? How come my pen is not working? Okay. There we go. Something's going on now. Okay. So to find u plus v, I'm going to add horizontal to horizontal. So this is going to be -5 plus -3. And vertical to vertical. 2 plus -6. So -5 plus -3 is -8. 2 plus -6 is -4. Okay, so I can show this. I could also do this on my graph. So I'm going to show vector u, which is -5, 2. So -5, 1, 2, 3, 4, 5, 2. We're going to do tip to tail. So here is vector u. Vector 3 is negative 3, 1, 2, 3, negative 6, 1, 2, 3, 4, 5, 6. So this is vector v. So my resultant vector is from the original tail to the tip. And when I box out this vector, the resultant vector, it's 1, 2, 3, 4, 5, 6, 7, 8, which is minus 8, and 1, 2, 3, 4, which is minus 4, which is the vector I just calculated. So minus 8, minus 4. So I should get the same thing, whether I'm calculating this algebraically or whether I'm doing this graphically. All right, let's do another one. All right, let's do v minus 2u. So v, here we go. V is negative 3, negative 6. So this is negative 3, negative 6, minus 2 times u, and u is negative 5, 2. So this kind of works like the distributive property. So I have negative 3, negative 6, negative 2 times negative 5 is positive 10, and negative 2 times positive 2 is negative 4. So now I'm going to add the horizontal to the horizontal. So negative 3 plus 10 is negative 7. And negative 6 plus negative 4 is negative 10. So I could do, I'm going to start with v. Here's my origin. So v is negative 3, negative 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is v. And negative 2u. So negative u is going to be positive 5, negative 2. And I want 2 of those. So positive 5, 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. So negative u, negative u. So my resultant vector is here. So I'm going to box out my resultant vector. My resultant vector is 1, 2, 3, 4, 5, 6, 7. So 7, you know what? This is a plus 7. Negative 3 plus 10 is plus 7. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So minus 10. So plus 7 minus 10 is my vector. And my goal is graphically and algebraically, I'll get the same thing. Okay, perform the following operations algebraically. So this time I'm going to work with them in the I and J format instead of the vector format. Okay, so u plus v. So this is going to be, when we're showing them with u plus v, I'm going to use parentheses. So minus 5 I plus 2j plus negative 3I plus 6j. So this is adding like terms. So I add the i's to the i's, which are the horizontal component, and the j's to the j's that are the vertical component. So negative 5I plus negative 3I is negative 8I. And 2j plus 6j is 8j. So 8j. So when I show them, like the i's and the j's, I put them in parentheses. But when I show them as a vector, I don't have the letters I and j. So that'd be negative 8 and 8. Okay, so let's try u minus v. So u is minus 5I plus 2j minus negative 3I plus 6j. So I want to distribute the negative 1 first. So negative 5I plus 2j plus 3I minus 6j. Negative 5I plus 3I is negative 2I. And 2j minus 6j is negative 4j. So as a vector, I would say this is negative 2, negative 4. Okay, I can also do it scalar. So I'm going to say 3 times u. So, oops. 3 times u. Well, I guess we want to still see what all the vectors are. So we'll leave it like this. Okay, so 3 times u, which is 5, negative 5I plus 2j plus a half of v, negative 3I plus 6j. 3 times negative 5I is negative 15I. 3 times 2j is 6j. Plus a half times negative 3, so that's negative 3 halves I. A half times 6 is 3, so 3j. Okay, so negative 15 is negative 30 halves. So this will be negative 33 halves I. 6j plus 3j is 9j. So plus 9j. So this is also negative 33 halves, 9. Okay, to find the magnitude. So to find the magnitude, I'm going to use A, where I know the vector, the resultant vector is 8 by 8. So I'm going to use that over here. I know the resultant vector, is negative 8 by 8. So the Pythagorean theorem is going to be negative 8 quantity squared plus 8 squared, which is going to be 2 times 64, which is going to be 8 times the square root of 2 for exact answer, and rounded would be about 11.314. So if I want to find the magnitude of vector u plus the magnitude of vector v, these I would add separately. So the magnitude of vector u, I'm using the Pythagorean theorem, so this is going to be -5 quantity squared plus 2 squared plus vector v is -3 quantity squared plus 6 squared. 5 times 5 is 25, plus 2 squared is 4. That's going to be the square root of 29. 3 squared, -3 squared is 9, plus 36 is 45. So this is going to be the square root of 45, which is 9 times 5. So 3 times the square root of 5. So this is going to be equal to the square root of 29 plus 3 times the square root of 5. Exactly. And rounded, that'll be 12.093. Okay, next I want to find vector u plus v into polar form. Okay, we've already found that the resultant vector is -8, 8 from A above. So looking at that, if I plot my point, -8, 8, -8, 8 is going to be something like this. Okay. So I want to solve, here's an angle, a reference angle, but I want to know what is this angle here, theta, and R is here. So R equals, so R is the hypotenuse, so this is -8 and 8. So -8 quantity squared plus 8 squared, taking the square root. So that's 2 times 64, which is going to be 8 times the square root of 2. And then to find the angle, I have to find the reference angle. So the reference angle is going to be the tangent inverse of y divided by x. So 8 divided by -8. And I'm going to get that this is -45 degrees. And I get that because the reference angle also matches over here. So these two angles, so I have to interpret what the calculator is telling me. So the calculator is telling me that this is -45 degrees. So this is -45 degrees. So my theta is really going to be 180 degrees minus 45 degrees. So my reference angle theta is 135 degrees. So in polar form, this is 8 square roots of 2 and 135 degrees. Okay, so this one really is important. You draw the diagram so that you understand how to interpret what the calculator told you. Okay. Okay, so next, in polar form, I have vector 8, vector u as 8 and 45 degrees, and vector v 6 at -45 degrees. Convert u and v to component form, and then add. Okay, so if I want to draw a diagram to get an idea what's going on here, 45 degrees is in the first quadrant. And a radius of 8. Since it's a 45 degrees, I know 45, 45, 90. So to find x and y here, and then v, let's draw v. So v is at negative 45 degrees and 6. So this is negative 45 degrees and 6. Okay. So I want to calculate x and y and both triangles, and then I'm going to add the horizontal components together and the vertical components here, and I wrote those backwards. Okay. All right, so x, so we said x equals r times the cosine of theta. So substituting in, I get 8 times the cosine of 45 degrees. Cosine of 45 degrees is the square root of 2 over 2. So simplifying, I get 4 times the square root of 2. To find y is r times the sine of theta, which is 8 times the sine of 45 degrees. So 8 times the square root of 2 over 2 when I substitute, which again is 4 times the square root of 2. Okay, and then for my second triangle, I get x is 6 times the cosine of minus 45 degrees. So 6 times the square root of 2 over 2, which simplifies to 3 times the square root of 2. And y equals 6 times the sine of negative 45 degrees. So this is going to be 6 times negative square root of 2 over 2, which is negative 3 times the square root of 2. So now I'm adding my horizontal components together, and I'm adding my vertical components together. So 4 times the square root of 2 plus 3 times the square root of 2 is 7 times the square root of 2, and I'm going to add 4 plus the square root of 2 minus 3 times the square root of 2, which is the square root of 2. So my final answer is 7 square root of 2 square root of 2. Okay, so a real world application of this is a ship or a moving object. It could be a car, it could be anything. So a ship is on a course of 108 degrees at a speed of 15 knots. Find the north-south component of its velocity vector and find the east-west component of its velocity vector. So we're talking about a ship. So these are compass directions. So north, south, east, west. And it says I'm at a course of 108 degrees. So here's 90. 0 is at north. So 108 degrees is here. So this is 18 degrees here. because 90 plus 18 is 108. Okay, so the north-south component is my y, or my vertical component, and my east-west component is my x. So while I'm talking about compass directions when I'm drawing this, when I'm applying the trig, I have to use it in standard math. So I am setting this up of saying I'm solving for, here's x and here's y. So this is really negative 18 degrees in the math. So this is the sine of negative 18 degrees is y. So 15 knots is my radius or my magnitude. So y divided by 15. So y equals 15 times the sine of negative 18 degrees, which is 4.635 knots, 4.635 knots, and we say south because I'm going down. And the east-west component is cosine, so cosine of negative 18 degrees equals x divided by 15. So x equals 15 times the cosine of negative 18 degrees, which is 14.266 knots east, because I'm going to the right. And that's it.